Okay guys, so in this video we are going to talk about the acidity of phenol, basically the acidity of phenol, and compare it with the acidity of ethanol, uh, an organic compound which we also did in AS, ethanol. Okay, it's basically CH3, CH2OH, and phenol is a derivative of benzene containing an OH group as a substituent. Okay, now before we proceed further, let's talk about acid first. What is an acid? Well, acid can be defined in three different ways. According to the Bronsted-Lowry definition of acid, Bronsted-Lowry definition of acid, acid is any substance that is a proton donor. Proton, basically by proton we mean the H positive donor. It donates H positive ions. So basically if I have HCl over here and in aqueous solution, the HCl it dissociates to donate its proton H positive ion aqueous and the Cl negative ion aqueous. So it has basically donated its H positive ion. So this is a Bronsted-Lowry acid. Okay, now the second definition of an acid is the Lewis definition of acid. Lewis. And according to Lewis definition of acid, acid is any substance that is an electron pair acceptor. Electron pair acceptor. So anything that accepts electrons is a Lewis acid, is basically an acid according to the Lewis definition. And the third definition is according to Arrhenius. And according to Arrhenius, any substance that dissociates an aqueous solution to produce H positive ions. So anything that produces H positive ions in aqueous solutions is a Arrhenius acid. Okay, so these are the three different definitions of acids. The more important ones are Bronsted-Lowry and the Lewis definition of acid. Lewis definition of acid, well, basically, we've also done an example of Lewis acid. Remember the AlCl3 catalyst that we used in electrophilic substitution? It is a Lewis acid. Basically, it accepts electrons from the chlorine atom while we were doing halogenation reaction. The chlorine-chlorine molecule, it reacted with the AlCl3 catalyst. So how did it react? Basically, this chlorine atom over here, it donated its electron pair to the aluminum atom. So basically, this molecule is accepting electron pairs. So any substance or any compound that accepts electrons is a Lewis acid. Okay, now this is for acids. So basically, this is what these three definitions cover acids. Okay, now let's talk about the strength of acids. Okay, before we go on to the strength of acid, let's also discuss about bases. So for a base, what is a base? Basically, for a base, you just need to reverse the three definitions. Base is Okay, base is any substance that accepts protons rather than donating it. Let me write it over here. Okay, now what is a base? According to Bronsted-Lowry, base accepts protons. Okay, base accepts protons. According to Lewis definition, base donates electrons. It donates electrons. Acids accept electrons, bases donate electrons. And according to Arrhenius, base is any substance that produces OH negative ions in aqueous solution. So these are the three definitions of bases. Just a big recap of AS. Now let's get going and talk about the strength of the acids. strength of the acids. Okay, strong acid and weak acid. Strong acid by definition, any acid is strong if it fully ionizes in aqueous solution. Fully ionizes in aqueous solution. For example, if I take HCl and if I place it in aqueous solution, it would fully dissociate into H positive ions aqueous and chloride negative ions aqueous. This is a strong acid. So HCl is a strong acid. Now, as compared to the strong acid, which is a weak acid is any acid that is partially ionizes in aqueous solution. So weak acid, it partially ionizes in aqueous solution. Partially ionizes in aqueous solution. Okay, examples of weak acids, basically the organic acids that we have. Organic acids, which include methanoic acid, ethanoic, propanoic, butanoic, they are weak acids. For example, ethanoic acid, CH3COOH, is a weak acid. Why is it a weak acid? Because it partially ionizes in aqueous solution. Not all the protons are donated, but rather only CH3COO negative ion is formed and H positive ion is formed. So this acid basically partially ionizes. It is not fully ionized in aqueous solution. That's why it's a weak acid. Okay, now we've discussed these. This was a bit basic intro on acids and bases.